This week on the show, we're adding glue to a desktop environment. We're also flashing the BIOS on a PC engine. We also revive a Cisco IDS into a capable OpenBSD computer, as well as an OpenBSD WindowMaker desktop setup. And we show a little bit about real-time data compression, as well as the love for pipes in this week's episode of BSD Now. BSD Now, episode 286, Old Machine Revival, recorded on the 20th of February 2019. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And we have a new episode for you, and for the people who haven't seen it yet, we also have a freshly facelifted website. That's cool and exciting. So, Alan, I think you can tell us a little bit more about that.
I don't know, it's just the podcast network is switching to this other system, and it builds the website a little easier and handles the show notes and so on. It's less work for us, and it should mean that the show notes appear on the BSD Now site as soon as they're available, rather than they were often quite delayed.
Okay, so yes, we have a little bit of freshness in that department, and we also have, as every week, headlines for this little episode of us. Adding glue to a desktop environment is the first one.
Yeah. So I say in this article, we'll put some light on a lot of the tools used in the world of the Unix desktop environment, specifically for customization. Talking about things like WMCTRL, which is Window Manager Control, Window Manager Utilities, X Environment, X Truss, Window Info, lots of other gobbledygook of names here.
Utilities,
including one called Trigger Happy. If those names don't make sense, then this article is here to help. So a lot of the questions regarding these tools and what they're usually for don't actually grasp the purpose of a window manager or what a desktop environment actually is. So they want to talk a little bit about that. First, X and other bits about X Windows in general. Then taking the X framework and adding a window manager and a desktop environment, which are actually not quite the same thing. Trends and evolutions of the window interfaces, as you know, it's been quite a few years since the first versions of X came out, and the way we interact with computers is a little different now. Then it talks about making everything faster or plainer, and then looking at actually writing a window manager and how an X window manager works. But even without reading all the previous content, this article will explain how to customize things a little better. Mm-hmm. So this one looks a little bit at how to debug things, how window manipulation actually works, how to simulate interactions, how to extend those manipulations, and then how to set up hotkeys and layout managers.
Oh, very nice.
So when you have an X server, it'll have multiple windows, and then you can also have a toolset in a window manager that will interact with those windows. And it talks a bit about how, window manipulation is, windows are just objects that are living in the X server and have some visual representation when they're mapped to a screen, which is when stuff shows up on your screen. Windows, like any other objects, have attributes and properties attached to them. Another interesting object within the X server is the pointer or the cursor, where you actually interact with the windows. The tools in this section manipulate those bare objects using the X11 protocol to speak to the X server. They do things such as list the identifiers of the window objects within the X Windows server, so you can get a list of all the windows that exist and their basic properties, or that you do things to them such as moving them, resizing them, changing the order that they're stacked in, or labeling them, hiding and unhiding them, and so on. So two popular tools for these functionalities are WM Utils, which is obviously your window manager utilities. And there's another one that's just called the window utility, which comes from the X11 Extras package on Debian. And it allows you to do things along with other utilities used for Windows listing, such as WinSelect, you can kind of get an idea of what's happening in the interface. Then you can also simulate interactions using tools like WinMacro to actually make up a macro. So when you want to do certain operations, you don't have to do each step manually. You can basically script that.
That could
or
be useful.
You can do extended manipulation. There's a standard called ICCCM, the Interclient Communication Conventions Manual, which was devised in 1988. And another one called the Enhanced Window Manager Hints. That was not long after, built on top of it, and allows you to do things to different windows. And it talks about the hotkey daemon and how to use something like Xbind keys to make your own keybinds. And also a layout manager like GTAL for GNOME or a grid manager for other window managers and so on. And then if you're familiar with truss on FreeBSD, which can let you see the syscalls that an application is making, there's xtruss to actually see the X calls that an application is making, which help you understand what it's doing.
And I guess most people are familiar with xkill.
I've never used that, but yeah.
Really? You never had a stuck window to just kill it with the little bomb icon?
No. That'd be interesting, though. Anyway, if you're interested in understanding how X works, or even digging deeper into the series into how you actually write your own window manager, well, check it out. It's got lots of good stuff in there if you want to actually get into customizing what your computer looks, what your interface looks like, or even building your own window manager.
And also the interaction between these different components in the X server.
Yep.
Very nice. But that's not all that we have for you today. We have also the headline Flashing the BIOS on the PC Engine's APU 4C4 by Sean Webb here on GitHub. He posted that because apparently he loves the PC Engine's APU devices, so he wrote a little bit about it. He writes, I use them for testing hardened BSD experimental features in more constrained 64-bit environments and firewalls. Their USB and mSATA ports have a few quirks, and I bumped up again a major quirk that required flashing a different BIOS as a workaround. So this article details the hacky way in which he went about doing that. And the reason for this hacky way is because the upgrade of OpenSense from 18.7.10 to 19.1 failed partway through, leaving him in an unbootable system state. What prompted this article is that something in either the CAM or the Guillaume layer in FreeBSD 11.2 so caused the mSATA to hang, preventing the files to be written. And apparently OpenSense 18.7 uses FreeBSD 11.1, whereas the recently released OpenSense 19.1 uses hardened BSD 11.2. So don't get confused here with the version numbers. He reached out to PC Engines directly, and they let him know that the issue is a known BIOS issue, and flashing the legacy BIOS series would provide him with a working system again. And so it happens that a new legacy BIOS version was just released, which turns on ECC mode for the random access memory, and he gets a working OpenSense install and ECC memory. Good combination, I would say. And so, although he's using an APU 4, these instructions should also work for the other APU devices. The BIOS ROM download URLs should be changed to reflect the device you're targeting, along with the BIOS version you wish to deploy. And of course, special note, there be dragons, be careful, make backups. All these things could crash and burn anytime. So he's primarily writing this article to document the procedure for his own purposes. And yeah, there could be errors in there, so be careful what you type into your terminal. So let's get on with it. First, you need a few things before to get started. First, some kind of hardened BSD installation image or OpenSense, whatever BSD you want to use. And he uses the memstick image since he's going to boot off a USB thumb drive. And here's the instructions how to burn that to the USB stick, in case you don't know how to do that. And Next up is you plug in the memory stick into your APU, attach your serial cable to your system, and then connect to it using the famous CU utility. And next up, you
basically just a serial client.
Yeah. And then you set your COM console speed in the serial console access and COM console, of course. And then you hit boot. And once this system is coming up, you'll be prompted with a terminal type selection. In this case, he entered Xterm. But I guess the other ones are just fine. It's just personal preference. Mm-hmm. And first, you're going to set up swap and then do the rest of the partitions. So these are a couple of gpart and swap on commands, or just one swap on command. And of course, activate your network interface. This is IGB 0 in this regard. And next, you would do the hardened BSD update to get the latest and greatest updates from hardened BSD. And then copy your resolve conf to mount root/etc to get that the DNS works in the change root, because you're in a very constrained environment there. And finally, you mount a defFS file system because that's also needed. And now we're actually ready to dive into the change rooted environment. So you do change root/mount/root. And he added a very special extra crucial note. Make sure that you're downloading the right BIOS for your system. Do not blame him if you simply copy the next 3 commands verbatim without first ensuring they apply to your system. So you could basically just brick your system by using the wrong BIOS version. But if you pick the right one, then you do package install the flash ROM software and ch _root _nhs to get the latest certificates. And then you can use fetch, and then you basically extract that archive you downloaded from their website, and then use flash ROM -p internal board mismatch equals force, and then the name of your ROM.
Yeah,
and that should be it.
The board mismatch thing is the one you have to be especially careful with. And basically, normally the tool will not write the BIOS to it if it doesn't claim to be for the same type of board. But if you know what you're doing, just make sure you definitely have the right image.
Yeah, otherwise you just have a very expensive doorstop.
Mm-hmm. And I don't know if the APU is actually heavy enough to be a useful doorstop.
Yeah, so less use than even being that. Okay, so yeah, make sure that you don't mess this up, but afterwards you can enjoy the newer version and without any hassles that they had before. Now it's time for the news roundup this week. First, we revive a Cisco IDS into a capable OpenBSD computer.
In which they appear to have turned Puffy into a submarine and have some bombs attached to the side of it. It's a little weird.
Well, anyway, that's cool.
I say, even though Cisco equipment is very capable, it tends to become end of life before you can say planned obsolescence. Websites become bigger, bandwidths increase, and as side effects of these improvements, routers, firewalls, and in this case, intrusion prevention systems get old quicker and quicker. Apparently, this was also the case with the Cisco IDS 4215 intrusion detection sensor that I was given a few months ago. I'm not too proud to admit that at first I didn't care about the machine itself, but rather about the add-on PCI network card with 4 fast Ethernet interfaces. The sensor was had obviously seen better days, as it had a broken front panel and needed some cleaning. But upon a closer inspection under the hood, which was held on with 4 screws, the IDS consisted of an embedded Celeron PC with 2 onboard Ethernet cards, a 2.5-inch laptop hard drive, a compact flash card, and 2 PCI expansion slots. Oh, and a nasty server-grade fan that pushed very little air but made a lot of noise. Mm-hmm. So first they replaced the fan with a sleeve-bearing 80mm Cooler Master, so it'd be much quieter. And they talk a bit about that. Storage-wise, the IDS has a 256 megabyte compact flash card, probably has a boot drive, and a 40 gigabyte IDE hard drive for data. I replaced the hard drive with a 120 gigabyte version, and because I happen to have one on hand, but held on to the original compact flash card. But then they look at the rest of the system, which is a passively cooled Celeron PGA 370 socket and 2 sticks of RAM, giving you 512 megabytes of RAM. And it has 2 Intel 82559 Pro 100 fast Ethernet cards connected via PCI, and a USB 1.1 port and a standard Cisco RS-232 console connector, but no onboard video or audio, making it a perfect embedded network appliance. And they have some pictures here if you want to see what it looks like. But they go about installing OpenBSD on it, especially since, with no video output or console redirection, you need to be able to do all this kind of headless. So they grabbed the latest OpenBSD from one of the mirrors, and then they slapped the i386 image down, put the mini-root FS, put that onto the compact flash card and inserted it into the slot. Then they booted it up, plugged in the console, the Ethernet, and the power, and then connected to the serial port. And you can actually see the Cisco BIOS booting up, then starting OpenBSD. They configured the console and so on, and then it boots up.
Nice.
And then they went through the install and installed OpenBSD to the hard drive.
Not too bad.
So at that point, they killed the power, removed the compact flash card, and closed it up again, and then booted it up. And they say there's a couple of caveats. These machines have no ACPI, and as a consequence, no power management. They can't shut down from software, and they can't do wake on LAN or anything like that. A graceful shutdown is performed by halting the machine and then turning the power switch off. Also, the PCI bus has problems with interrupt allocation, making it impossible to use both of the expansion slots in their attempts, although it might be possible by making a couple changes to the BIOS or to OpenBSD. They say it's possible to upgrade the RAM, hard drive, and even the CPU. Just make sure that the power consumption stays under 50 watts, because that's all they get from the power supply. And they swapped the 4 interface 100 megabit card for a gigabit one. You can put many PCI cards inside the machine. However, only one of the slots ever seems to work at once. And if preferred, OpenBSD can be installed on a bigger compact flash card, not needing the hard drive. But that's not what they did. Yeah. Nice way to turn one of those old machines into something useful again.
Yeah, it doesn't have to go to waste. It can do its little service or whatever you purpose the machine for. Just as well. But that's not all we have about OpenBSD this week. We also have an OpenBSD desktop using WindowMaker. And this is starting like the following. Since the author here of this article started using Unix, they've regularly used WindowMaker. They've always liked the look and feel, the dock system, and the dock apps. And it may look a bit oldish nowadays, and it's enough to try to change this. So here it is, a 2019 flavored WindowMaker setup running OpenBSD 6.4 on AMD 64. First thing to do is to install the binary packages. So VM, all of those other names that could have are only required to achieve the final look. So that's easy. You do package_add on OpenBSD to get WindowMaker, WMCal clock, and WMinfo, as well as WMMO. Then, as your normal user, because always don't run as root if you don't need root, run wmmaker.inst, which will install WindowMaker for the current user, create a couple of directories, and copying default databases and such. And now that you have a couple of extra files like the xinitrc, xclients, or xsession scripts updated, and after that's done, the installation is finished. Next thing is to tell the XenoDM to start WindowMaker when you log in. And if you use StartX rather than XenoDM or any other desktop manager, or login manager, replace the .x session by .xinitrc in the following paragraph by just removing or commenting out the user local bin WMaker line. Okay, and now you can log in and enjoy WindowMaker, and there are a couple of screenshots from the desktop, how it looks like. And yeah, this gives it a bit more of a fresh look. And a couple of other color configurations are capable in, like, for example, you do the Nord color scheme change or the Apta Nocto ETA GTK theme, and or maybe the Moblin unofficial icon set. And the author also did remove the applications icon because they don't need them at the bottom of the screen as heavily, and F11 is also there to pop up the window list. To be able to do that and keep the dock apps, they tweak the GNU step default config files, and they provide all these files for your tweaking and customization.
Yep.
Very nice. But now we get real-time data compression.
Well, I think that's just actually the name of the blog here. But this is a post by Jan Colette, who wrote LZ4 and Z Standard, talking about opaque types and static allocations. Referring to a previous blog post, he says, "We've seen that it is possible to create opaque types. However, creation and destruction of such types must be delegated to some dedicated functions, which themselves rely on dynamic allocation mechanisms. Sometimes it can be convenient to bypass the heap and all of its malloc and free shenanigans, pushing a structure onto the stack or within thread local storage. Those are natural capabilities offered by the normal struct and can be desired at times. The previously described opaque type is so secret that it has no size, hence is not suitable for such a scenario. Fortunately, static opaque types are possible. The main idea is to create a shell type with a known size and an alignment, able to host the target private structure. For safe maintenance, the shell type and the target structure must be kept in sync by using typically a static assertion that they'll be the same size. It will ensure that the shell type is always large enough to host the target structure. This check is important to automatically detect any future evolution of the target structure. Right? If you're creating a shell type that's going to give you enough room to hold the secret type, if the secret type grows and you don't expand the shell, you're going to end up with memory corruption. And it might be hard to figure out what it was, but the static assert will make sure that it won't compile if you make that mistake.
Oh, I see. Okay.
It says, if it wasn't for the strict aliasing rule, we could have a winner. Just use the shell type as the public user-facing type, proceed with transforming it into the private type inside the unit, and it would combine properties of struct without, or while still remaining opaque. But unfortunately, the strict aliasing rule gets in the way. We can't manipulate the same memory region from two pointers of different types for the lifespan of the stored value. That's because the compiler is allowed to make assumptions about pointer value provenance for the benefit of performance. And they even have a way to visualize this issue. They have a simple example powered by Godbolt. I'm not sure what that is. Anyway, notice how the 2 + 1 get combined with a single +2, saving, or doing +1 twice is combined into doing a single +2, saving the extra save and load round trip and allowing the compiler or the computation over the variables to happen in parallel. But unfortunately, if f and I are actually the same address, then the result you would get would be wrong. And it explains why compilers do it this way.
Mm-hmm.
Interpreting differently the same memory area using different types of pointers is called type punning. It may work as long as the compiler serializes the operations as expected in the code, but there's no guarantee that that will continue to work safely in the future. A known way to break older programs employing type punning is to recompile them on a modern compiler using things like -03 or link time optimization. With enough inlining, register caching, and dead code elimination, one will start to experience strange effects which will be very hard to debug. And he has a link to where this is explained in greater detail in an excellent article by Mike Acton. For even deeper understanding of what could be happening under the hood, you can read the documentation that he provides here from Josh Simmons on how compilers work and so on. One line of defense could be disabling use of strict aliasing by the optimizer with a compiling flag like -f no strict aliasing for GCC. I wouldn't recommend it though. On top of impacting performance, it ties code correctness to a specific compiler setting, which may or may not be present in the user's project if they're embedding this compression, or if they happen to be using a different compiler. Portability is also impacted since there's no guarantee that this capability will exist in other compilers. Another line of defense consists of using the char pointer, which is the exception to this rule and can alias anything. When one memory area is passed as a character pointer, the compiler will pay attention to serialize the reads and writes properly. It works well in practice, at least in all of Jan's tests. What is worrying, though, is that in theory, the compiler is only obligated to guarantee the read is in the correct order. That it pays attention to serialize the write too seems to be just extra care the compiler is taking, which it might decide not to do someday in the future. And this is presumably done so that existing programs continue to work as intended. Not sure if it's reliable, depend on that in the long term. And so another issue is our proposed shell type is not a char table, it's a union containing a char table. That's not the same, and the exception doesn't hold true in that case. So as a consequence, the shell type might not be, or might not be confused with the target type, and the strict aliasing makes these non-interchangeable. So the trick the trick is to use a third-party initializer to convert the allocated space and return a pointer to the appropriate type. To ensure strict compliance with the C standard, it's a multi-step trick, hence a more complex setup, considering this technique as advanced, implying limited usage scenarios. So they actually have some example code of how they do one of these.
Interesting. Yeah, looking at the code. So yeah, this reminds me of my programming lectures where they always say you can make suggestions to the compiler, but the compiler itself can decide to do it either unoptimized or in a different way, so you can only hint, but don't rely too much on how the compiler behaves, because it could do something else that you don't expect.
So it ends with, to avoid direct accesses of structured members, one can still mention it clearly in code comments and use scary member names as a deterrent. A more involved way to protect struct members is to give them scary and useless names, like don't access me 1 and don't access me 2, and renaming them with macros in the code section, which can actually interpret them. Is a bit more involving, especially if the number of member names is large, potentially leading to confusion. Also, more importantly, the compiler will no longer be able to help in cases of contract violation, and protecting the design pattern will now entirely depend on reviewers, which may be not the best way to do it. Still, it's a very reasonable choice, notably the internal types, which are not exposed to the user-side API, and should only be manipulated by a small number of skillful contributors subject to review process. For user-facing types, though, opacity is more valuable, and if the type size is large enough to begin with, it seems like a no-brainer. Prefer the opaque type and only use references. This is mostly in this case talking about, I think, the Z standard API and so on, but we've kind of learned this lesson for OpenSSL, where a lot of the internal bits used to be exposed to the users of the API, and this caused people to do a bunch of things they probably shouldn't. And then, whereas in the newer version of OpenSSL, one of the things they did in the API was start making a bunch of those opaque. So you have accessors and getters and setters and so on to access the internal bits, so that you aren't just randomly poking at them. And this has caused a lot of programs need to be changed. So deciding to do it the right way in your API in the first place can make a big difference.
Mm. Oh, yeah. Okay. What's next? Oh, yes, you will like that, because this is about the love of pipes, or for the love of pipes, actually. So this is over at Jesse Frizzell's blog, and we thought this would be a nice homage to the pipe concept in Unix. So she writes, my top used shell command is the pipe. This is called a pipe. In brief, the pipe symbol, or the pipe, allows for the output of one program on the left to become the input of another program on the right. Gee, I feel really reminded of my lecture today. It is a way of connecting two commands together. For example, if I were to run echo hello, I get the output hello. But if I run echo hello pipe figlet, the figlet program changes the letter in hello to look all bubbly and cartoony. This is a really blunt way of describing something that, in my opinion, is brilliant software design, but I will get to that in a second. So let's get back to the origin of pipes. She writes, according to this link here, which is a Cathedral and Bazaar link, I think. Not sure. The origin of pipes came long before Unix. Pipes can be traced back to this note from Doug McIlroy in 1964. And the note says basically, summary, what's most important? To put my strongest concerns into a nutshell. First, we should have some way of coupling programs like garden hose, screw in another segment when it becomes necessary to massage data in another way. This is the way of I/O also. Second,
I think that makes a lot of sense. The garden hoses have a standard male and female connector basically, and you can just add another segment or change the head, right? Like if you're watering the garden, you probably want a spray nozzle, but if you're trying to just water the lawn, you want one of the automated ones that goes back and forth or whatever, but all of them have the same connector. And so having pieces that, where you can just change out what it's connected to and make it do something different or filter the content differently makes a big difference.
Mm-hmm.
Or, you can get the spray nozzle for your garden that has a little add-on pod that mixes fertilizer in to make your flowers grow or whatever.
Oh, you have that? Nice. Yeah, we might as well put some extra juice into it. But that's beside the subject of pipes. The second thing that he writes, our loader should be able to do link loading and controlled establishment. I guess it has less to do with pipes. Yeah. Okay, so that's part of his notes here. And so the Unix philosophy is documented by Doug McIlroy as, first, make each program do one thing to do a new job, build afresh rather than complicate old programs by adding new features. Second, expect the output of every program to become the input of another, as yet unknown program. Don't clutter output with extraneous information. Avoid stringently columnar or binary input formats. Don't insist on interactive input. And the third here is design and build software, even operating systems, to be tried early, ideally within weeks. Don't hesitate to throw away the clumsy parts and rebuild them. And number 4, use tools in preference to unskilled help to lighten a programming task, even if you have to detour to build the tools, and expect to throw some of them out after you've finished using them. And so this is from the Bell Systems Technical Manual, or Technical Journal. Mm-hmm. And so she continues writing, what I love about Unix is the philosophy of do one thing well, and expect the output of every program to become the input of another. This philosophy is built on the use of tools. These tools can be used separately or combined to get a job done. This is a stark contrast to monolithic programs that do everything or one-off programs used to solve a specific problem. System programs and commands like echo, which we saw above, output information to your terminal by default. For example, cat will concatenate, its namesake, those files and print the results to your terminal. While reading Program Design in Unix, another book here, I realized that printing the output of the tool to the user's terminal was actually the special case. quoting here, perhaps surprisingly, in practice, it turns out that the special case is the main use of the program, unquote. When a user redirects the output of cat via the pipe to some other programs, cat becomes so much more than what the original author intended. This is one of the most brilliant design patterns, in her opinion. And not just her. For one, programs being simple and doing one thing well makes them easy to grok. The beautiful part, though, is the fact that in combination with an operator like the pipe, the program becomes one step in a much larger plan. The original author of cat does not even need to know about the larger plan. This is the beauty of the pipe. It allows for solving problems by combining small, simple programs together.
Right. So if you think about the person who originally wrote cat, or even the version of cat that's in your operating system, which, well, maybe has been modified a little bit recently, is still pretty close to the original one from, say, the 80s. Well, the thing, if you look at the last 100 times you use cat, how often did you pipe cat into something that didn't exist when cat was created? Good chance it's at least half of it. And so the fact that it was designed to be able to just be the input for some unknown program that maybe doesn't even exist or won't be invented for 20 years is really what made it interesting.
Yeah, and the flexibility built in there is just great, because a lot of people can dock into these pipes and use their own. So she closes her article with, "I love software design that enables creativity, values simplicity, and doesn't put users in a box. The pipe is a key element for keeping programs simple while enabling extensibility. A simple program in combination with a pipe becomes so much more than what the original author could have dreamed of." And closes with, she hopes that this post helped you learn something, if not just pipe to death null. So after this little reminiscing of pipes, we have BSD bits for you, starting with installation notes for NetBSD i386 0.9. Wait.
Yeah, so this is from the very early 90s. So this came up in a Facebook thread, I think started by Michael Lucas. And anyway, it got way off topic, but at some point somebody posted the pictures of what they found in their basement earlier this week. And it includes the installation notes for NetBSD 0.9. And so I thought some people might be interested in that. It talks a little bit about, be sure to read all of this document before you try to install NetBSD. NetBSD probably looks a little familiar from things that you've done before, like 386 BSD, but the install procedure is quite different. NetBSD is a Berkeley Networking Release 2, or Net/2, derived system. I always find it interesting that was the way to describe it back then. I remember up until like 2014 or so, the FreeBSD website still described FreeBSD as being derived from something similar to that. And it's like, I don't think most people know what that is anymore. It is no longer a good way to describe what that version of BSD was. Anyway, it goes on to say, it's a fully functional Unix-like system, which runs on several architectures and is being ported to more. And goes on, is currently binary compatible with FreeBSD and somewhat compatible with 386 BSD. And, most programs that will work on one of the other BSDs will probably compile on NetBSD and so on. But then they have some interesting bits, including a heading, "The Future of Mit Bsd." They say, "We hope to have regular releases of the full binary and source tree, but as these are difficult to coordinate, this can only happen if someone volunteers for the job. We intend to integrate free positive changes from whatever sources will provide them, providing that they are well thought out and increase the usability of the system. This includes integrating changes from 386 BSD 0.2 when it appears, as well as from 4.4 BSD. I think 386 BSD 0.2 appeared like last year, right?
Yeah, not too long ago.
Yeah, like 20 years later. I say, above all, we have to create a stable and accessible system and to be responsive to the needs and desires of the NetBSD users, because it is for and because of them, that NetBSD exists. And then it goes on to talk about how to get NetBSD from FTP.
Okay, yeah. Where else would you get it?
Hopefully, the sources for the distribution will become available in the near future.
Yeah, I mean, what's a day or two?
Yeah.
Okay, yeah, I hope you enjoyed this historic piece. We also have porting ZIG to NetBSD, a fun and speedy port, listing how that effort started or how it went. So ZIG in itself doesn't need it to bootstrap. This is seen as a mark of mature languages, and indeed ZIG is an earlier phase for development than others, but it makes porting so much easier. Contrast this with Rust that continually needs anyone porting to build their own bootstrap kits repeatedly and updating them fairly often, the author writes here. So like Go, ZIG attempts to provide an alternative to libc, and Go has made the same choice and has logic to do the syscalls itself. They've eventually discovered that this is a bad idea for some operating systems that don't consider syscalls the compatibility boundary, but system libraries like Darwin and Solaris, and had to offer the option anyway. And so they talk a little bit more about the porting efforts. So while ZIG has its own build system, the building of ZIG itself begins with CMake, a very standard tool. It was so standard that package sources CMake logic automatically did everything for him. So perfect. And of course, someone has done a port to FreeBSD, so paved most of the way to a NetBSD port. Thanks for that. And yeah, you can see the example output down here. Yeah, so this is good start, I think.
Yep, I've not heard of this language before, but there seems to be kind of a run on writing new systems languages all of a sudden.
Apparently, something is picking people's interest or scratching their needs.
Yep. So then we have NNN. Noise is not noise. A noiser fork. This is apparently a tiny, lightning-fast, feature-packed file manager, and has released version 2.3, and you can get it over here on GitHub.
Mm-hmm. Cool. We have also ETA, a tool for monitoring progress and ETA of an arbitrary process. This GitHub.
It's actually, the GitHub link is wrong, I just noticed.
Oh, okay. Then we fix it in the show notes, and so you don't get confused.
Mm.
So let's go with the next one. A FreeBSD user tries out NetBSD 8.0. This is a YouTube video that we have, so this is an interesting experience for someone who is using a different BSD. Yeah, and check out the video. I guess you will find some interesting things. Maybe you find some things that you also did wrong on your first other BSD or didn't know what to do. So yeah, this is a nice way of reminding yourself that although the BSDs are similar, they're still in certain details a little bit different.
Or a lot different, depending on what part of the system you happen to be looking at.
Yep.
So next we have an OpenBSD post about faster VLAN forwarding. So this is actually based on a story we covered 2 years ago. They observed that when used a VLAN, performance suffers from the additional locks that were added to the queuing API. At that time, the use of SRP was also pointed out as a possible regression that could have been responsible for the degradation. Since then, DLG at OpenBSD recently reworked the if and queue API to allow pseudo drivers to bypass the use of queues and their associated locks. So let's dive into the performance of the VLAN interface again. So here we repeated the measurements we did 2 years ago using a profiling kernel to see where CPU cycles are spent. I'm publishing these data gathering on the same host, an E5 2643 V2, which is 3.5 gigahertz. And they actually show graphs for both the single-threaded and the 6 cores, and show that before and after the change, you can see that suddenly VLANs have a much smaller penalty.
Good.
So the number of forwarded packets per second is a relatively small because almost 2/3 of the cycles are spent on the actual profiling. However, it is interesting to see that the number dropped from 880 packets per second to 535 packets per second for plain forwarding. This is coherent with other performance degradations observed after applying the CPU workarounds. I think they might be referring to like Spectre and Meltdown for that.
Probably, yeah.
And then they have some charts breaking down the before and afters of the IX and VLAN locking queues and so on.
Mm-hmm. So yeah, this is a noticeable difference.
Mm-hmm. So they say currently, if in queue, the changes did improve the situation. So what's next? They say the first difference that appears in the graph is VLAN input, and it is being consuming 2.5% of CPU time, roughly the amount of time we're not spending on the interrupt handler. Most of this time, 1.7%, is used to enqueue the packet again using mutexes and the SPLs in the if in queue input. Another noticeable difference is that if get, this seemed weird at first, that both if in queue and VLAN transmit needed to call this function, accounting for about 1/3 of the calls each. But the reason for that was a hack that had already been removed, special casing for MPLS tunnels.
Uh-huh.
And then they also looked at plain forwarding on a 6 CPU machine. Analyzing global profiling data gathered on multiple CPUs is a challenge. But they first tried without VLAN and then with, and then more results. So the conclusion is that data analysis is hard. Why are the proportions of forwarding packets different between single processor and multiprocessor with and without VLAN? How relevant or correct are these measurements? It's hard to say. If they're doing the measurements with profiling on, it's definitely hard to say. I say, at least we know that the previous speculations were not completely wrong. We're happy to see that DLG's fix is improving the situation. We have an idea about what the next bottleneck is. And, is it on the input side? We have some good guesses about further micro optimizations that we might be able to make and see how this stack behaves on more than one CPU. On top of that, I want to thank Hirovi Popovsky for doing the data collection. Plus, we found an old scheduling bug thanks to the profiling info, and that got fixed as well.
Oh, excellent. while here, fix this other thing as well. Yeah, Cool. Nice results. And next, we have a system called Fuguita, which is OpenBSD 6.4 live system, made available by Yoshihiro Kamawata. And what is this? It's a live system which was based on OpenBSD operating system and has the following features. So it has a similar to HDD installation. So this live system is intended to be similar to the HDD installation as much as possible. And after the bootstrap is completed, you can log into the environment like the one which you're used to just installing it on HDD. And in that environment, many ordinary files have replaced or have been replaced to symbolic links. So you can replace them or modify them by yourself. It's also a portable workplace. So you can save your own environment to floppy or USB flash drives, and you can retrieve it the next time you boot. Or it also features low hardware requirements. Unless you will use X, this live system requires only 64 megabytes of memory to run. And it's tracking OpenBSD stable and is applying all the errata patches.
Yep. Also, they have support for ARM64, so they have it running on a Raspberry Pi 3 as well.
Oh, nice. That's also a thing we should look forward to. Do you know if this person is presenting something at Asia BSDCon?
I do not know off the top of my head.
Mm-hmm. Well, this would be the perfect venue to display it or show it. Okay, maybe we'll see someone using that or the author itself.
Next up, we have an OpenBSD story about how to do name-based hosting on Nginx with OpenBSD and the Acme client.
Okay, that sounds interesting.
Basically, how to set up vHosting based on different host names, and and get certificates for all those host names using Let's Encrypt.
Yep, good certificates from Let's Encrypt. And yeah, this is pretty straightforward as a how-to. It shows you the required Nginx server sections, and in your Nginx conf, what other tweaks you can do for the ciphers.
Yep,
Yeah,
it's got all the bits you need. And they have a great example there with hackingforfoodbanks.org.
Worthy efforts. Okay. Mm-hmm. Very nice.
Next up, we have an example of the NetBSD stuff we talked about recently, which is actually using the Intel Haxum system. So this, if you're interested in that new virtualization system that we talked about in 1 or 2 weeks ago, they now finally have a tutorial.
Ooh, cool.
So the author here says, I learned that Camille was taking up the challenge of porting Intel Haxum to NetBSD. I found this to be a great learning opportunity to learn about OS development. So I decided to help him and check whether his demo of Windows 7 really worked. Below are the steps I've taken to actually get it running. So this post is meant to be a guide to setting up Intel Haxum accelerated version of QEMU on NetBSD 8. The Haxum capable QEMU is currently provided in the package source work in progress QEMU-Haxum port. Apart from that, a kernel patch provided by Camille is necessary to actually have Haxum support. Below are the steps needed to get all this up and running on a vanilla NetBSD 8 system. So first, you want to make sure that your CPU is an Intel CPU that has the VTX support. So they show how to use LSCPU to double check that. And then you want to grab the source code for your version of NetBSD so that you can apply the kernel patches, including the FPU DNA patch they specifically talk about here. Apply those patches, then compile the new kernel and reboot onto it. Then install NASM, the assembler, and then check out the Intel Haxum code, and then go into the NetBSD directory in that tree and compile it, and then load the Haxum kernel module that makes. Then you also want to grab the work in progress version of the next package source release and install QEMU Haxum. And then once you've done that, they have a little shell script here for creating the Haxum devices for your different VMs. And then here they say Windows will run only as 32-bit guest for now, due to Haxum not emulating the CR8 register that Windows needs. But shows you how to go to Microsoft and download a pre-built Windows VM. Then we can extract that and use QEMU image to convert it from a VMDK to a QCOW, and then fire it up using QEMU.
And here are the screenshots for it. Wow.
Yeah, basically it's your totally normal QEMU invocation with -excel Haxum, and that will use Intel's hardware-assisted virtual machine engine. And they also show examples of running FreeBSD 12, Minix 3, Plan 9, Haiku, and lots of other things.
Hey, nice.
They couldn't manage to get Windows 10 working. It was hanging in the loading screen. And if they made it have less than 4 gigs of memory, it complained about RAM. It couldn't create its RAM disk. They have a GitHub issue for OpenBSD 6.4, has a general protection fault by the look of it. And Solaris 10 crashes in the bootloader. And ReactOS has a blue screen of death during device detection.
Okay. Well, but it's a good start for a couple of operating systems.
And they found that trying to run Windows XP actually hung the host. Oops.
Oops.
Trying to run Windows NT 4, the Windows installer is broken even under unaccelerated QEMU. And under Windows 98, it has it issues a vCPU shutdown request, and that stops emulation, and then nothing ever happens.
Well,
but yeah. This is pretty interesting because using an accelerator like the Intel Haxum thing and then a generic front end like QEMU means you get a lot more support for the older devices. Although, one of the advantages to Beehive was not having that all that old emulation
Legacy
code, including, say, the floppy emulation, which has been a source of major vulnerabilities in QEMU a number of times.
Yep. But yeah, it's nice to have a choice, and maybe we'll see a couple of performance numbers from Haxum in the future. So yeah, what's left? In this section, we have, the README for GCC 7 switch coming to a port near you. This is also on NetBSD's mailing lists, and goes like this. Hi folks, from Matthew Green. I plan to switch AMD 64 and ARM 64 to GCC 7 soon. i386, Spark, whatever Spark, MIPS, PowerPC, and Alpha are probably ready and tested enough for anyone else to try out. The 32-bit ARM is only just now working, so not well tested yet. HPPA, M68K, VAX, and SH3 all built but have not been tested yet. IA64 and PowerPC 64 are currently not building, and I haven't looked at it. Hopefully, I revived hopefully revived RISC-port yet, or the OR1K. And if you'd like to help test, now from the NetBSD current version, build a clean tree with build.sh -V and then _GCC equals 7, and it should just work.
And as it says, if you need to switch back, just do the same, but with have GCC equals 6. But make sure you do a complete clean build, otherwise you could have problems. Quickly rewinding for a minute, I got the fixed URL for that ETA tool for monitoring the progress of an arbitrary process.
Yes. So that we have that complete in the show notes. And
so this, basically you give it the target value and a command to inspect the current progress, and it will keep doing it. So in this example, I think they're doing an SCP of a file, and on the other side, they're comparing the size of the directory on the two different sides of the SCP and generating a progress bar for you. So even though they're copying multiple files, which gets individual progress in the copying side, on the receiving side, you can compare the size of the directory on the source and destination and get a progress bar.
Yep.
Here's another one where they actually are monitoring the number of files in a directory and getting progress that way. Or by tailing a log file.
Yeah, it has many uses.
Or by counting lines, and so on. Lots of good examples.
Yeah, so check out the tool and maybe build it in your own scripts, or make good use of it. So since we have
even have the last example here where it's counting down, but knows that that's progress. So it's how many files aren't converted yet, and then counting down until it's 0.
Oh, yep. Yeah, same result. Yep.
Yeah.
Since we were...
next section, I broke it out into its own little section just because it got a little big to tack onto the end of BSD Bits this week. I grabbed a bunch of upcoming meetings for various BSD user groups. So if you're in Chicago, the Chibug will be meeting Tuesday, February 26th at 1800 at the Oak Park Library. There's a link in the show notes that'll send you to where that is. And they expect to have pizza delivered at 6:30, so make sure you show up.
Yep, there's also Charmbug in Baltimore. It's on Thursday, March 7 at 7 p.m. at Columbia Ale House. Okay, I guess I know what they're serving, but it's not required to actually drink one. Just hang around with a couple of people, like-minded folks in the BSD area.
Actually, that's the wrong date somehow. I'm not sure how I screwed that up. The Charmbug meeting is Wednesday, February 27th, so you need to come sooner.
Oh, right, yeah. So yeah. You'll have it in the show notes later, so
Yes.
we'll update that.
Yes, Wednesday, February 27th. Don't know how that got messed up.
That's fine. Or just look at meetup.com/charmbug and you get always the dates from there.
Yep.
The other user group in New York City is, of course, Nicebug, and they are meeting Wednesday, March 6th at 6:45 at Suspenders.
Yep, that's their usual place. And the speaker will be Amitai Schreier talking about maintaining Qmail in 2019.
Interesting. Well, worth visiting. And also there is Knoxbug in Knoxville in Tennessee. It's on Monday, February 25th, and it's at 6 p.m. at the IX Systems offices. Go to knoxbug.org for more information.
Yep. And in Europe, you missed the Swedish meetup. I think it was last night. But the Polish user group has their meeting on February 28th at 6:15 at the Wheel Systems offices.
Yep. So wherever you want to meet other BSD folks, I guess this calendar is growing, and which is a good sign that the BSDs are actually not dying.
Yep. They will be talking about the kernel crash dump feature in FreeBSD, and also tuning systems in Polish.
Yeah. But yeah, it's a meeting in their language, so that they will have ways to.
If you happen to be in Warsaw,
understand.
it's likely you can manage to understand most of the talks that way.
Yeah. All right, so enjoy those meetings, and we're coming to our feedback and questions section for this week. As always, we need more questions to fill this section. Send everything that you have or that you always wanted to know to feedback@bsdnow.tv. So the first one is Sam this week with a question about customizing OpenBSD ports source code. He writes, "Hi, Alan and Benedict. I was using Ubuntu Mate for quite a while, but decided to try out FreeBSD after having watched your show for some time. We're doing something wrong, Alan, don't you see?" So yeah, he also started using i3 around the same time and used the FreeBSD port system to customize it a bit, and also changed the default color of the menu and customized i3 so that it would bring up a binary clock when he brought up the i3 status bar using the Windows key. And he recently decided to try using OpenBSD after having accidentally stuffed up an update and messed up the config files. Ooh. He managed to install it and set up everything and how he likes it, with the exception of the things mentioned above.
So customizing i3.
Okay, so his problem is that he cannot figure out how to edit the source code of a port on OpenBSD and then do a make install on the modified version of the port. He knows this may be a simple question, well, we also take those, but I'm not really sure where or how to find the answer. Any explanations or advice you have on how to do this would be greatly appreciated.
Yeah. I'm guessing the OpenBSD ports tree has something equivalent to make extract that FreeBSD does, where it will download the tarballs or whatever and extract it, and then you can go in there and modify it before you do the make to compile it all and the make install to install it. I'm not at all familiar with the OpenBSD ports tree, but I don't think it's all that different, other than a bit more of it is in Perl instead of makefiles, I think is my understanding.
Yep. And also, isn't it also possible to install it via package source and using their system?
You could use package source on OpenBSD, but because OpenBSD has its thing, I imagine that's more useful.
Maybe someone from the OpenBSD camp can tell us, and we'll update people in the next episodes about
it's strange
the
that
proper
i3
way.
makes you compile it different to get a different color instead of having that be a config setting, but...
Or maybe you can take over the config file from FreeBSD and put it into the one from
But
OpenBSD.
I don't think it's a config file thing. The other option is to basically fork i3 on GitHub or somewhere, or basically download the source code, modify it, host it somewhere, and then make your own port that's, i3-sam that downloads that source code and compiles it using the same compiling options or whatever, but using your modified version of the source code.
Yeah, that might be something, and it will also give you a little bit more understanding how things work and are put together. So yeah, good luck with your future endeavors in the BSD country, and if you get stuck in some other rock, then we'll be here to help. Next person to ask us a question is Frank about the rivalry of Linux and BSD. Hello, Alan and Benedict. In the first place, thank you very much for the great podcast. You're welcome. That you always manage to make. Oh yes, we manage that every week. Yep. So he writes, I'm mainly a Linux Ubuntu user, and for storage I use FreeNAS. I'm extremely happy with both systems, although there's a certain thing that I find very unfortunate, and that is the rivalry between the Linux and the BSD community. I actually see more similarities than differences. I'm fairly new in the field of Linux and BSD, and therefore not really aware of all the politics involved. But this is how I look at it. It is not more logical to eventually merge both systems or bring them closer together. I fully understand that many folds need to be smoothed out, and I might be very naive, but this is a really sad state to see how divided the open source community is and how they fight each other. Some posts on the internet are actually pretty frightening. And we can learn so much from each other. For example, the developments about ZFS. Do you see a future where there is a kind of BSD/Linux combination? Thanks again for all your work in the community.
Well, it's interesting looking at the rivalry between Linux and BSD, or even other BSDs and so on. It comes down to what scale you're looking at. If it's going against Windows or something, then kind of Linux and BSD are on the same team and they're friends. They're fighting the good fight. Or other times it's all of the various BSDs and even the Lumos fighting the monster that is Linux. Or some days it's just FreeBSD versus OpenBSD or whatever.
The fight of the day.
So it really comes down to what the argument's about, who ends up on which side. And yes, I think a lot of it is just a waste of time when we could be doing work instead of arguing. But trying to do a combination of Linux and BSD, there are many reasons why it doesn't make sense.
Unlikely.
The first is that they're not all that close together. The bigger problem is obviously licensing. The fact that it's a two-way street in one direction, but a one-way street in the other direction, if that makes sense. Code from BSD can go into Linux, but code from Linux can't come back to BSD.
And I see this at conferences a lot where, like FOSDEM, where we just went to, and it's just a lot of people there, and they tolerate each other, what systems they're using, or what other choices they had in their operating systems, or whatever. And there's a lot of, there's not much fighting going on, at least not in front of everyone. So it's just people hanging out, enjoying their open source software, and maybe one person is using X and the other person is using Y, and that's fine for each other. I have the same in so you have two companies sometimes that are, if you look on the news pages, they're really against each other, like fighting all the time. But if they're at a customer, they have to, and the customer uses both systems, whatever that might be, or products, then both of these have to work together because the customer wants them both to use in its own environment. So I kind of think this is a similar environment where there are similarities and there are also differences, but depends on which use case or in which environment they both reside. For example, in your case with FreeNAS and with Ubuntu, that's perfect combination and it works and it's not closing out the other system.
Right. And there's the other thing of, if we only have one system, if we actually did combine BSD and Linux or whatever, that would probably be worse. Having some choices when it comes to something can actually be really beneficial, because sometimes it comes down to, we need to decide how to do this, and so one team goes one way and one team goes the other way, and we don't find out for 5 years that one of them went the wrong way.
Yeah.
Well, the fact that it wasn't everything went down the wrong path instead of only part of it maybe ends up saving us or whatever. And we have this thing about monocultures. If everything piled into OpenSSL, like it kind of did, then it meant that when there was a bug in OpenSSL, it affected everybody. If only half the people used OpenSSL and half the people used something else, then if there's a problem with OpenSSL, you can also temporarily change until OpenSSL gets fixed, or at least not every single thing ends up being vulnerable. And this is why companies like VeriSign, that host the .com root domain, purposely use both Linux and BSD in hopes that when there is a critical vulnerability, it won't affect every one of their servers.
Yeah, and the variety and the choice that people are given in the Unix environment sometimes can be a bit overwhelming. But in case you are looking for something new, there's a lot of choice out there. And I guess
maybe it's a slightly contrived example, but if we made a genetically modified version of a potato that had all the nutrients you needed, would you want to only eat potatoes for the rest of your life? Every once in a while, you'd want something that's not a potato.
Yeah, it could get boring after a while. So I encourage you to go to maybe an open source conference where you have a chance to meet both parties, if you want to call it that. And then you would see that the spirit is actually quite open and friendly, and people actually are working together in many ways, not just fighting all the time.
But, even just trying to combine two of the BSDs that are out there back together is probably not that easy an undertaking. It probably wouldn't be worth it. And so, it doesn't seem to make sense to try to combine Linux and BSD. Not just for the licensing reasons either.
Yeah.
But thank you for the question, Frank.
Yeah, that was good. All right. Zach is our last question asker here about MySQL and MariaDB tuning. Starts like this. Greetings, Beastly gents. Your show has helped me quite a bit over the years. Oh, great. That's good to hear. I've gone from being a knucklehead project manager to a paying gig as a Linux admin/engineer and a side job as a FreeBSD admin. Whoa, great. Congratulations. Good. Still a knucklehead, though. Okay, my Google foo, or rather DuckDuckGo has failed me at finding performance tuning tips for MariaDB as a data store for a PHP 7 web app on FreeBSD. We're running a few small sites in jails on UFS. The MariaDB docs only have some general suggestions, but that aren't super helpful. I did notice there are 1 or 2 packages in the ports collection that can make suggestions on performance tuning, but I wasn't sure of how accurate they were. Can you give me an idea on how to start?
It really depends. As with all stuff, it's very specific to your workload. And so it's mostly a matter of measuring the performance you're getting, figuring out which part of it is the slowest, and then what you can do to address that. If the MariaDBs or MySQLs happen to be running on ZFS, there's some specific tuning there. It's covered in the advanced ZFS book that Michael Lucas and I wrote. But mostly it's setting the record size to match the page size of the database engine you're using in MariaDB, and having that as a separate data set, basically. And then possibly having a slog or something to deal with all the synchronous writes. But outside of that, if the sites are relatively small, they're probably going as fast as they're going to go. Like they're not making anything get to 100% utilization on the system. And so, you don't have a problem yet necessarily. Also, more RAM will always help.
Yeah. So maybe just switching one of those sites from UFS to ZFS and see whether it performs better is a good test.
It also depends, depending on the workload, sometimes it's actually better to, even if you are using ZFS, to turn the caching down on ZFS and up in the database engine, like MySQL or MariaDB, and it's my.cnf or whatever, and have it do it because it maybe knows better. But at the same time, with compressed arc now, sometimes it's better to actually tune that one down and let the arc do it, because the arc will do it compressed and will save, will fit more data in RAM, or more data in the same amount of RAM because of the compression. But in that case, using larger record sizes gets better compression. So more data is fit in memory. But in the end, if it's a small site and the whole database is, under a gig or something, then you can already fit it in RAM without compression, and maybe it doesn't matter.
Yeah. Maybe someone else has a suggestion, but I guess these are careful measuring and then make small adjustments and see whether it gets worse or better. And yeah. But he has more questions.
The biggest one is change one thing at a time.
Yeah. Otherwise, it's screwing with your results, and you don't know, did that change it or the other knob? So yeah. He also asked, what's the best source of documentation on kernel tunables and sysctls for FreeBSD? So there's sysctl/d or -d for descriptions of the...
We'll add a description for each one. There's a man page called tuning and some stuff in the handbook, especially on ZFS, although the ZFS one, there are some new tunables on 12 that I don't think are covered yet. In a lot of cases, you can do more harm than good twiddling those tunables. So sometimes there's a bias towards not documenting them, although I don't think that's the right answer either. Mostly it's just they have so many effects, it's very hard to document everything that might change because you change that tunable.
Yeah, so don't over-tune it before you can really see an improvement.
But really,
and
it
last
comes
question,
down to, you have to figure out what is what the problem is right now, and then try to address that and just iterate on that repeatedly.
Yeah. Monitor your systems and see what the changes look like in the graphs or in the numbers. The last question he has in the PS, do you ever get tired of answering ZFS questions?
Not really, no.
Yeah, it's so exciting what people are using this file system with integrated storage manager for, or volume manager, and it's just, yeah, it never ceases to excite me. And I guess Alan is the same. Alan's looking probably more from the development side of it and bigger use cases. But yeah, it's just an amazing file system. Because previously you would in the installer, file system, yada, yada, I don't need it anymore. But now with ZFS, you get a lot more ideas. It's kind of, the ideas are springing out of that file system. Oh, now I could do that, or I could do this way. And so maybe that's the reason why ZFS, and it's also growing and expanding in new features that we're going to see in a couple of months, days, weeks, I don't know. So it's interesting to see the development and how it gets better every time. All right, I think that's covering that for this week. Thanks for watching this episode. And again, if you have anything that you want to see in the show, ideas, questions, maybe a blog post that you find interesting about the BSDs, send that to feedback@bsdnow.tv. We're also looking for interview people. Because we should do a couple of interviews for the upcoming episodes.
We have some travel coming up, obviously, with Asia BSDCon and so on, so we need to get some interviews in. It's just been a bit hectic lately.
But that shouldn't stop you from contacting us in case you want to sit in front of a microphone and tell us a little bit about your BSD experience. Thank you all for watching, and see you next time.